One of the special skills you should develop during your study of gases is a mixture of gas chemistry and stoichiometry. To begin, let's review what we know about gas volumes when they are measured at the same temperature and pressure. It's called Avogadro's hypothesis. Avogadro, way back in 1811, found that equal volumes of any two gases at the same temperature and pressure contain the same number of molecules. So if you have 1 liter of hydrogen and 1 liter of oxygen, and they are both at 25 degrees Celsius and 1 atmosphere pressure, there are equal numbers of hydrogen and oxygen molecules. Now we know from the balanced equation that 2 moles of hydrogen will react with exactly 1 mole of oxygen to form water vapor. But from Avogadro's hypothesis, we can conclude that 2 volumes of hydrogen will react with exactly 1 volume of oxygen if they are at the same temperature and pressure. That means that in a chemical reaction, if everything is a gas at the same temperature and pressure, the mole ratio of reactants and products is the same as the volume ratio. So let's solve a problem using our hydrogen and oxygen reaction. Hydrogen and oxygen gases are mixed. They are at 200 degrees Celsius and 1.0 atmospheres pressure. If there is 250 milliliters of hydrogen, how many milliliters of oxygen are needed for the reaction, and how many milliliters of steam would be produced at that temperature and pressure? Here is the equation. 2 moles of hydrogen react with 1 mole of oxygen to form 2 moles of steam. But if they are at the same temperature and pressure, the mole ratio is the same as the volume ratio. Therefore, 2 volumes of hydrogen will react with 1 volume of oxygen to form 2 volumes of steam. Here is our setup. The number of milliliters of oxygen needed equals 250 milliliters of hydrogen gas times the ratio 1 milliliter of oxygen gas divided by 2 milliliters of hydrogen gas. Multiplying by this ratio tells us that 125 milliliters of oxygen gas are needed for the reaction. Anything over that would be excess oxygen and not reacted. Here is the setup for the steam product. The number of milliliters of gaseous water produced equals 250 milliliters of hydrogen gas times the ratio 2 milliliters of water vapor divided by 2 milliliters of hydrogen gas. Multiplying by this ratio tells us that 250 milliliters of steam should be formed at that temperature and pressure. Now let's ask how much hydrogen would be needed to react completely with 44 liters of oxygen at the same temperature and pressure. Here is our setup. The number of liters of hydrogen needed equals 44 liters of oxygen times the ratio 2 liters of hydrogen divided by 1 liter of oxygen gas. Multiplying by this ratio tells us that 88 liters of hydrogen would be needed for the reaction. Anything less and the oxygen would not be completely used. Anything more and we have excess hydrogen. Avogadro's hypothesis has been helpful once again to turn volume stoichiometry into a very simple process.